What if a comet's tail pointed the wrong way? On October 25, 2025, interstellar object 3I Atlas was confirmed to have a tail aimed directly at the sun. This physics-defying anomaly triggered quiet, urgent protocols from global space agencies, now tracking a visitor that breaks all known rules of our solar system. What is this mysterious object, and what strange forces are guiding its impossible journey? Let's delve into it. The impossible tail. What if I told you that an object in space was defying the sun itself? Every comet we have ever observed follows a fundamental rule. Solar winds and radiation pressure blast dust and gas away from the nucleus, creating a tail that always points away from the sun. It's a foundational principle of cometary physics. But in late October 2025, images from the Gemini South Observatory in Chile captured something that makes no sense. The interstellar object 3I/Atlas was sporting a narrow defined tail of material stretching in the wrong direction, straight into the solar glare. This isn't a faint or ambiguous observation, it's a high-resolution image of a direct violation of celestial mechanics. Dr. Casey Leese, an expert in comet composition, has spent his career analyzing how solar forces shape these objects. A phenomenon like this would be outside any known model. It's like watching smoke flow back into a fire. The initial reaction was disbelief, a hunt for an optical illusion or an instrumental error. But as other observatories confirmed the data, the chilling realization set in. This wasn't a mistake. The impossible was happening.
Emergency protocols.
When an object in space defies known physics, it's not just a scientific curiosity, it becomes a global priority. Almost instantly, 3I Atlas was flagged for reprioritization across major space agencies. Internal anomaly detection systems on the James Webb Space Telescope sent directives to switch its observational focus, a process that normally requires weeks of peer-reviewed proposals. The Hubble Space Telescope began tracking it more aggressively. This triggered internal protocols at NASA and observation drills within the European Space Agency's Planetary Defense Office. NASA's Planetary Defense Officer, Lindley Johnson, leads a team whose entire job is to prepare for celestial threats. While 3I Atlas posed no impact risk, its deeply abnormal behavior required the same level of scrutiny because any object that doesn't follow predictable physics is an unknown variable. It became a high-interest non-local object, and the world's most powerful eyes were quietly retasked to watch its every move, with data streams being shared across international lines with an urgency typically reserved for imminent threats.
The sunward plume.
So, what exactly are we seeing? Is it really a tail? At first, astronomers theorized it could be a powerful forward-facing jet. Comets sometimes develop geysers when a pocket of frozen gas bursts from a sunlit surface, but as Dr. Michael Comby, an expert on cometary atmospheres, could attest, those events are typically brief, chaotic, and faint. They don't form stable, tightly focused plumes that last for hours or even days. The plume from 3I/Atlas wasn't just a puff of gas, it was a sustained, columnated blast, like a controlled nozzle firing directly toward the sun. To make matters stranger, the comet also displayed a faint, ghost-like countertail extending behind it, just as expected. So now the question wasn't just about the plume in front, it was about what could possibly be powerful enough to overcome the immense force of the solar wind. Was it a stream of incredibly heavy dust particles, a column of high-energy ions interacting with the sun's magnetic field in a way we've never seen? Or was it something else entirely? Because if this plume really is a tail, then it means 3I/Atlas isn't just reacting to the sun, it's actively interacting with it.
Chemical anomaly.
Just before the impossible tail made headlines, the James Webb Space Telescope delivered a chemical analysis that, honestly, just deepened the mystery. Its infrared spectrometer found a staggering 8-to-1 ratio of carbon dioxide to water vapor being vented from the object. To put that in perspective, this is an unheard-of ratio for comets in our solar system, which are typically water-dominant because they formed past the so-called frost line, where water ice is abundant. Even the last interstellar visitor, 2I Borisov, wasn't this extreme. This finding, championed by NASA scientists like Stephanie Milam, sent shockwaves through the astronomical community. CO2 sublimates at much colder temperatures and far more explosively than water ice, which could explain the powerful plume. But it implies the object formed in a star system profoundly different from our own, maybe a carbon-rich environment where water was scarce. Or, more speculatively, it could be the frozen exhaust from an ancient, long-dead technology. This chemistry is so alien, it really forces us to reconsider the building blocks of planetary systems elsewhere in the galaxy.
Nickel without iron.
If the strange plume and chemistry weren't enough, the next discovery from the Keck Observatory in Hawaii, well, it really pushed things over the edge. The spectrograph detected vaporized nickel in the comet's coma, but with one glaring omission: there was no detectable iron. In astrophysics, this is like finding smoke without a trace of fire. Nickel and iron are cosmic partners. They're forged together in the hearts of stars and form the cores of rocky planets. They vaporize under similar thermal conditions, and every asteroid, comet, and meteorite we've ever studied, where you find one, you find the other. Until now, leading experts in extraterrestrial materials, like Dr. Philip Heck, have built careers on analyzing these elemental pairings to understand an object's origin. The absence of iron in the presence of nickel simply shouldn't happen in nature. A fringe theory emerged involving exotic nickel-carbonyl compounds, which are rare and fragile, even in labs. But some researchers noted another uncomfortable fact. These same compounds have industrial applications in metal purification. This may be an irrelevant coincidence, but when you have an object that moves strangely and has a bizarre chemical profile, the idea that you might be seeing something synthetic is, frankly, hard to ignore.
Silent escalation.
This string of anomalies triggered a quiet but significant shift in the global observation network. This isn't about panic, but about priority. The International Asteroid Warning Network began running trajectory drills using 3I Atlas as the simulated object, highly unusual for a non-impacting body. NASA's SphereX mission, designed for infrared sky mapping, had a portion of its bandwidth redirected. Even the Swift telescope, which usually hunts for high-energy gamma-ray bursts, was nudged to observe the object. Detlef Koshny of the European Space Agency has noted that this kind of cross-agency retasking is reserved for high-priority events because telescope time is a fiercely competitive resource. Diverting an asset like Swift means other important supernova or black hole research gets put on hold. Observers reported quiet inquiries about sharing targeting schedules, a practice normally used for fast-moving objects or potential impact threats. No one was smashing a red button, but the silent escalation was clear. The world's space agencies were treating 3I Atlas as a profound enigma that demanded immediate answers.
Trajectory deviation.
You know, it doesn't just look weird, it's moving weird too. As 3I Atlas got closer to the Sun, orbital models showed a small but persistent deviation from its predicted path. It wasn't just following the curve of gravity. This phenomenon is called non-gravitational acceleration, and, well, we've seen it before. Comets outgas, and that venting acts like a tiny, natural rocket engine. But the deviation in this object's trajectory didn't quite align with the expected forces. Instead, it seemed to be influenced by the impossible sunward plume. This brings back some uncomfortable memories of Oumuamua, the first interstellar visitor from 2017. As Professor Avi Loeb famously argued, Oumuamua also accelerated without a visible cause, leading him to suggest it could be an artificial object. Unlike Oumuamua, 3I Atlas is visibly releasing material. Still, the math doesn't quite add up. The drift isn't matching the intensity of the gas release. Some analysts have even floated a truly wild theory to explain the discrepancies, that the object is so massive or exotic that it's causing a tiny, localized warping of spacetime, a pocket of time dilation that alters its path. It's an extreme idea, but with 3I Atlas, no theory is off the table.
The AI flag.
Perhaps the strangest detail came not from a human, but from an algorithm. Publicly accessible logs showed that weeks before the tail anomaly was widely known, the James Webb Space Telescope had flagged 3I Atlas for manual review. It wasn't a command from an astronomer but a trigger from its own automated AI system. This AI, similar to models like Morpheus developed by astrophysicist Brant Robertson, is trained on tens of thousands of known objects to recognize what's normal. It flagged 3I Atlas because its light curve, the pattern of its brightness as it rotates, didn't match a typical tumbling comet. A natural object usually has a chaotic, uneven surface, producing a messy light curve. This object's curve was just too rhythmic, too clean. Some suggested it could be due to smooth, flat surfaces reflecting light in a predictable way. The fact that an AI built to ignore noise and find true anomalies essentially raised its hand and said this doesn't fit anything I know is incredibly rare. It suggests the object has physical properties fundamentally different from any natural body in its training data.
Ancient omens.
When the sky changes, humans pay attention. It's an instinct baked into our DNA. For thousands of years, comets were not seen as scientific curiosities but as omens. Babylonian astrologers recorded tailed stars as signs of war and the fall of kings. Ancient Chinese astronomers called them broom stars, believing they could predict floods and dynastic shifts. According to Dr. E.C. Krupp, a leading expert in archaeoastronomy, these celestial events were deeply woven into the fabric of human history and belief. When a blade forged from meteoric iron was found in King Tut's tomb, it was seen as a sacred gift from the heavens. Today, our reaction is different, but the underlying tension is the same. Instead of court astrologers, we have Reddit forums and YouTube channels exploding with orbital graphs and spectral analyses. Theories of alien probes and cosmic warnings go viral. It's easy to dismiss this as superstition, but perhaps it's a recognition of something profound. When the cosmos breaks its own rules, it forces us to look up and wonder what it all means.
The facts.
So, let's ground ourselves in what we know for certain. 3I Atlas was officially discovered on July 1, 2025, by the Atlas Survey in Chile. Atlas stands for Asteroid Terrestrial Impact Last Alert System, a robotic survey designed to spot dangerous near-Earth objects, making its discovery of an interstellar one an ironic twist. It's the third confirmed interstellar object, following 1I Oumuamua in 2017 and 2I Borisov in 2019. It is estimated to be between 5 and 11 kilometers across, making it a true celestial giant, far more massive and complex than the tiny cigar-shaped Oumuamua. Its closest approach to Earth is calculated for October 29, 2025, at a safe distance of 0.36 astronomical units, posing no impact threat. The world's most powerful observatories have all studied it in one of the most intense, coordinated campaigns in modern astronomy. Every piece of data is being scrutinized, not just to understand this one object, but to learn about the chemistry and physics of a star system we've never seen. We are left with a cosmic puzzle, a tail pointing toward the sun, chemistry that defies our models, a trajectory that doesn't fully obey gravity, and a global network of scientists working in silence to understand what it all means. As 3I Atlas approaches perihelion, its closest and most violent encounter with the sun, we are heading for a moment of truth. Will it break apart, revealing its internal secrets? Will it flare up, showing us materials we've never seen before? Or will it survive, continuing its impossible journey and leaving us with more questions than answers? The one thing we know for sure is that this story is far from over. What do you think is causing this impossible tale? Let us know in the comments. Don't forget to like, subscribe, and hit the bell icon so you don't miss our next update on this incredible story. Thanks for watching Stellar Tech.